There is this puzzle known throughout mathematicians called the three utilities puzzle. The puzzle is quite simple. There are 3 houses and 3 utilities: water, electricity, and gas. And you are supposed to connect all of the houses to each 3 utilities and not cross any connection lines. But attempting to solve this puzzle is rather difficult, and that's because it's impossible, which is quite a strange stretch on the word puzzle. But why exactly is it impossible, you may be asking? Well, to the few among you who know anything about graph theory, you might already see that this quote-unquote puzzle is actually a graph. Now, hold up. Some of you may be saying,
graph? This is just dots connected by points. It's not the thing I learned in algebra with an x-axis and a y-axis. There's not even any equations like y equals x squared or y equals sine of x. Well, what you call a graph is, yes, actually called a graph. But here in discrete mathematics, where we're talking about graph theory, it's what you're calling a graph is called a plot. To make room for these kind of graphs, the ones that are just vertices connected by edges.
But anyway, enough jabbering about what's called a graph, and let's talk about why this puzzle is impossible. Now, the task on hand is to see if this graph can be drawn without crossing edges. And graph theory already has a category for these types of graphs. They're called planar graphs, because they can be drawn on a plane. And so now all we have to do is to check if this graph is planar or not. But it doesn't seem very straightforward of a task. Or is it? Solving this with just 2 houses and then coloring in the areas that are enclosed, we get this very nice picture. But when we add the 3rd house, it causes trouble. Sticking the house where it should is in an area, which means any line coming from the utilities would have to intersect a line on the way to the house. Therefore, the puzzle is no puzzle at all. Well, again, is it? Because if you've seen this puzzle before, or you just Google the 3 utilities puzzle, you will find people saying that the puzzle is solvable on the plane, and it looks something like this. But I find a problem with this solution because in a plane where you can connect the top to the bottom and the left side of the plane to the right is no plane at all. It's a donut, or more technically speaking, a torus. And so yes, it is indeed solvable on a torus, and I guess topologically speaking, it's also solvable on a mug.
But I mean, come on. Who's ever going to try to solve the 3 utilities puzzle on a, well,